Relationship between molar mass, relative molecular mass, and relative formula mass. We use the relative atomic mass of the elements, forming a molecular compound, to calculate its relative molecular mass. We know that in a water molecule, there are 2 hydrogen atoms covalently bonded to 1 oxygen atom. Therefore, if we take a sample of water that has 1 mole of water molecules, it will have 1 mole of oxygen atoms and 2 moles of hydrogen atoms. In other words, if we take a sample of oxygen atoms, that is exactly 1 mole, and a sample of hydrogen atoms, that is exactly 2 moles, the combined mass will be equal to the mass of 1 mole of water. 1 mole of water has a mass of 18,004 gram. We can easily determine this from the relative molecular mass of water. Relative molecular mass of H2O equals 2 times relative atomic mass of hydrogen plus 1 times relative atomic mass of oxygen equals 2 times 1,007 plus 1 times 15,99 equals 18,004. 1 mole of water has a mass in grams that is equal to its relative molecular mass. In other words, the molar mass of water is 18,004 gram per mole. In the case of an ionic compound, discrete molecules do not exist. There are ions held together in a lattice. We consider a formula unit of an ionic substance. In the case of sodium chloride, the formula unit is NaCl. We use the relative atomic mass of the elements forming the ionic compound to calculate its relative formula mass. 1 mole of solid sodium chloride has a mass in grams that is equal to its relative molecular mass. Relative formula mass of NaCl equals 1 times relative atomic mass of sodium plus 1 times relative atomic mass of chlorine equals 1 times 22,98 plus 1 times 35,453 equals 58,433. The molar mass of sodium chloride is 58,433 gram per mole.
Starting to feel it? Now go master it with maskitv.